Good morning, everyone. So I see that we're running late, so I will try to keep my talk short. I will try to tell you more about Linux SRP Initiator support and the work I've been doing around that protocol recently. And I will not only discuss the SRP Initiator itself, but also the layers above it, current status of the Linux SRP Initiator, and possible future directions. My involvement with the Linux SRP Initiator is that I started contributing to that initiator and also the target several years ago. Last year I joined Fusion.io. That was for working on the Ion software. The Ion software is Sun software optimized for Fusion.io SSDs. That software consists of a storage core, command line interface, HTML user interface, also supports high availability, and of course has undergone thorough QA. Storage tech supports fiber channel, iSCSI, and SRP. So, and why SRP over InfiniBand? As Bernard Metzeler in his talk explained, for today's SSDs, the latency is so low and bandwidth so high that if you want to not to create a bottleneck with the storage network, that you really need InfiniBand. The reason we chose for SRP and not for another protocol is because of the Initiator drivers are available for several operating systems. And we are happy about the functionality and reliability of the SRP target, but we would like to improve the SRP Initiator further. As you probably know, the SRP Initiator in Linux is a kernel driver that has been implemented as a SCSI lower level driver. It does not only realize the SRP login, but also performs SRP command processing and error handling. And next to the kernel driver, there's also a user space process called SRP daemon. The role of that process is to scan the fabric for the targets, SRP targets that are available. And for those targets it finds, it performs an automatic login. The layers above the SRP Initiator are the SCSI core that calls the SRP driver itself to send SCSI commands. We have the SCSI error handler. If a cable is pulled, for example, the SCSI error handler kicks in. And if a command took too long, a timeout will be triggered. And if a timeout is detected, the SCSI command that failed will be aborted properly. And if it turns out that the abort fails because the target is no longer reachable, then further steps will be taken. That means try to reconnect to the target, and if even that fails, just offline the path. In a high availability setup, the multipath process has a very important role, that is detect which paths are still working, which paths are not working, and decide which paths to use for communication with the target. Current status of the SRP Initiator and high availability setup is that it takes between 2 and 3 minutes to detect a failed path. That is considered longer than acceptable for most users. Another open issue today, that is if a path failure occurs, that the SCSI error handler can decide to offline a path and that it's never usable again by the multipath daemon unless manual intervention occurs. Another particular behavior of the current SRP Initiator, that is, if a path failure occurs, that the corresponding SCSI host is removed entirely. That's undesirable because it makes certain use cases impossible, for example, host-side mirroring. If two targets are connected to one single host, and the host mirrors the storage over those two hosts, then that particular behavior of the SRP initiator can break the mirror after a path has been removed and reconnected. And the last issue of open issue is that SRP daemon only supports PK index 0, which means that it's not yet ready for proper InfiniBand partitioning support. Regarding path failure detection, there are several options to make the SRP initiator detect a failed path more quickly. One of them is to use the InfiniBand subnet manager, and that's the second option. First option is to use the HEA and to register for port error events. That allows to detect cable pull very quickly, but it only works for local failures. Second option is to use the InfiniBand subnet manager to register for trap type 65. That's the port out of service trap. That allows to detect link failures with a very low latency. But it only works if you use a managed InfiniBand switch, so that with an unmanaged switch, where the subnet manager is not running on the switch itself but on a host, this approach doesn't work. However, when combining the first two approaches, all failures can be detected with a low latency. But it's, the complexity of implementing that approach is significant. A fourth option I've been experimenting with is to periodically send a packet over the link, but in such a way that it's invisible or does not disrupt the SRP communication. The only possible approach I came up with was to perform a zero-length RDMA write that works well with Linux SRP targets, but not with certain other SRP targets. And fifth option is actually what I would like to prefer. That's to reduce the InfiniBand timeout. With today, the SRP initiator uses a timeout of 61 seconds before it reports a broken link. The easiest way to detect a broken link more quickly is to reduce the RC timeout. A proposal is to reduce it to 10 seconds. That should be sufficient to survive short periods of congestion or sporadic packet drops. So, as mentioned before, in order to support host-side mirroring, it's important not to remove a SCSI host after a path failure. So when a path failure occurs, and one way or another, communication has to be restored once the path is available again. So some software component has to trigger a reconnect to the target. One possible approach is to let SRP daemon trigger the kernel driver and to reconnect. However, that creates a dependence between the SRP initiator kernel driver and the SRP daemon process and user space. And several users are running the SRP kernel driver without the SRP daemon user space process. Hence a preference for implementing the reconnect mechanism in the kernel driver. So if we want to let the SRP initiator itself reconnect to the target, we need to implement some kind of finite state machine inside the driver itself. The proposal here is to modify the SRP kernel driver so that the behavior becomes close to what we have today in the Linux fiber channel initiator driver. That is to add two timers, fast IO fail timeout and dev loss timeout. These timers kick in after a communication failure has been detected, or for example after the target has sent a disconnect request. once connection has been restored, these timers are reset. And the proposed state machine is to start in the running state. That means communication working normally. If a failure is detected in the network, change the SCSI host state to blocked. That is a signal to multipath daemon that it should stop using that path and should start using an alternative path. At the same time, when a failure is detected in the network, the fast IO fail timers and the developers timers are started. If the fast IO fail timer fires, transport layer state is changed to failed. And if sometime later communication is still not restored and the developers timer fires, still invoke SCSI remove host. So this is how the fiber channel initiator driver works today in Linux. So that was regarding high availability. Regarding PK support, today the InfiniBand, the SRP initiator kernel driver, it has PK support, but the SRP daemon process not yet. It only supports PK index 0. My proposal is to add a command line option in SRP daemon that allows to specify the partition key and to translate that key into an PK index before a scan of the network, and also to let SRP daemon specify that PK during login. So. Yeah.
I just wanted to make a comment. Blake had mentioned this last week in User Day, the comment about the PK support. And on the users list, we just got a comment that on the Linux RDMA list, it appears they have addressed this. It doesn't say how, if it's your proposal or in some other way, but it appears that in later versions of SRP daemon and IB SRP DM, they do have PK support now. So you might want to check that out.
Well, actually, the support that has been added in the SRP daemon, that's work that I had done.
I'm sorry? Say that again?
The feature that has been added in SRP daemon is my work.
Other questions? You all set then? Great. Thank you for getting us back on time.